So, good afternoon, everybody. We're going to talk about circuits today. And circuits comes from the word circle. And that's why on our first quiz, we asked how many wires there are to a light bulb. And there's two, because that makes a circle. And the current flows around the circle, and it dumps its energy in the light bulb and makes light. So there's one little problem. Something has to make the current go around the circle. And that means that it needs a push or a lift or something. And that's something we're going to talk about next week when we talk about magnetism. So right now we're just going to take something called a power supply, and the power supply will push the current around the circle. So let's just assume that PG&E runs the power supply, or of course we could buy batteries, and you know that PG&E charges us something like 20 to 50 cents for a kilowatt hour. Batteries are about $100 for a kilowatt hour. So we're not going to use batteries. We're going to use a power supply and let PG&E push our current around the circle. So let's think about things that go up and things that go down. We're going to talk about going skiing, which is really fun. I hope some of you get to go skiing once in a while when there's snow. And you pay money to have something drag you up the slope to the top, and then you ski down. And that's what's fun, is the skiing down. But something has to drag you up, and you have to pay a lot of money for a lift ticket. So basically the power supply is kind of like the lift for the electrons. It lifts them up to a high place, and then they go down, and on their way down, they can do work for us, make light or run a motor or something. So let's just draw a circuit for one light bulb. So I'm going to say, let's have a little power supply here. And there's a power supply that would be on your desk if you were in the lab. And it's got two little holes. It's actually got more holes and lots of knobs. But we're just going to turn it on and take a wire. And we're going to run a red wire out of the power supply. And we're going to hook it to a light. And then we're going to take a black wire and run it back to the power supply. And lurking in here is a place where it's real hard for the current to get through. That's the filament of a light bulb. And when the current flows through it, the light bulb's going to light up. And if we open the circuit anywhere, pull out a plug or anything, the light goes off. But as long as the circuit is complete, the light lights up. Now here's the trick. We don't like drawing power supplies, and we don't like drawing light bulbs. So right away, I'm going to show you how to cheat. Instead of drawing a little box for a power supply, we're going to draw something that represents a battery. And it looks like this. It's a long bar and a short bar, and a long bar and a short bar, and a long bar and a short bar, as many as you want. And that is the power supply. And it can be set to some number of volts, like batteries that you know about. And then, hooked from the power supply, we're going to go across with a wire, and then we're going to come down to our light bulb. And we're too lazy to draw a light bulb. So we're going to just draw a little wiggly line that goes like this. And then the black wire continues down to the bottom of the slope, goes back home. And that is your simplest possible circuit for one light bulb. Hi folks, I'm back. My 9-year-old videographer has been helping me, and she picked up the two circuits that I drew for you last time, and she drew her own copies. And I hope you have been doing that, because just watching isn't the same as doing it. So today we're going to talk about a couple things. One is Ben Franklin, who got himself, he was in the 1700s, late 1700s, and he just guessed what was happening in these circuits. And he guessed that positive charges were flowing around the circuit from the top to the bottom, from what we call plus to what we call minus. And in the late 1800s, there was an experiment that showed that he was wrong. He just could have guessed right, but he guessed wrong. So every time we talk about current, we're going to talk about positive current flowing around the circuit. But what's really happening is electrons are flowing the other way. They come out of the black negative lead and they go around to the red top, okay? So that's what Ben Franklin's story, and he did the best he could, and he just guessed wrong. So we're going to talk just a little bit, and John will talk more about how we can put more than one light. Because I don't know about you, but you don't really want all the lights to go off when you turn one of them off. So the first thing you think of is, well, we'll just put them in a line, just put one after another, like old Christmas tree lights, which you don't remember. But we're going to make a circuit, which we're going to call a series circuit. And we're going to put the red wire at the top. And then we're going to come down and we're going to put one light bulb, two light bulbs, three light bulbs. I'm not doing this super well. And then go back. And we have now a perfect circuit. And the plus is up here, and the minus is down there. And we have three light bulbs, and John's going to do that for you. He's going to show it to you. This is called a series circuit, and I'm going to turn it around for you to see it, okay? And it's in a series because you have to do one, and then the next, and then the next. And the charges have to go all the way around, and they have to force their way through these little tiny filaments that make them struggle, and they make heat when they do it, and they basically use up their energy that the power supply gave them. It's kind of like skiing down three hills, okay? And there's only one path down this hill, and it's a series. So I should write series on here. Okay, so this is a series circuit. 1, 2, 3 in a line. And John will show you how that works. And as you can probably guess, if you take one light bulb out, the whole thing goes off. And that's not very practical. So suppose you've got a car and you have two headlights, and you'd really like to have those two headlights stay on. So what can you do? Well, I guess what you have to do is give each headlight a chance to have its own path for the circuit. So let's do this. Let's go from my power supply to one light and put it right here and go back. So then we've got one light, right? And now we're going to add another, but we're going to add it with its own. So we were making a parallel circuit. And parallel means three or more paths down the mountain for the electrons or the charge. And so we're going to have three lamps or more. You can have 3 or you can have 30. Sometimes there's a limit, of course. But this is called a parallel circuit, and if you unscrew one of the bulbs, the other bulbs still have their own path. So they're going to be fine, and if you turn off one light, the others stay on. And that's the trick with parallel circuits. If you turn off one light, that's fine. You can turn it off, turn it back on, the other lamps continue to burn, and you can turn any one off, okay? So John's going to show you that. That's a parallel circuit, P-A-R-A. L-L-E-L. Cut.
Hi Physics 10 Lab. I hope everybody's doing okay and staying safe and healthy and dealing with all this stuff as best you can. Sue and I miss you a lot and miss being able to have school. Here I am in my little home video studio, my little homemade improvised physics lab. Where I'm going to video some experiments for you. Of course, they're not as good as the real thing, but I hope it works. And please give us feedback about how well it works for you and suggestions. We're going to try to do as best we can to provide fun learning activities during this time. Okay, please take care. Bye. Here is our power supply, and what it does is it lifts electrons up to the top of the hill, gives them energy, and they can then fall back down and do stuff for us. I can turn it on with the green button, And I have a voltage knob that I can adjust the voltage, which is like adjusting how high the hill is, how much energy I'm giving to the electrons, or how high the hill is that they're going to ski down. And the electrons are going to be coming out of this terminal, the black one that's marked negative, and they're going to try to get to the one marked positive, but they can't go through the air, so we have to give them some way to get there. So I can put wires in here like that, and now they can get from one to the other. And if I connect these two wires together, they'll have a completely free path without having to go through anything, and that's called a short. And if I do it, the red light comes on and the power supply says, oh no, I have a short. But instead of going directly, we're going to make them go through something like a light bulb. So if I connect it here, now I have my light bulb, and I can connect the wires to either side of the light bulb, and the light bulb goes on. Now I have the light bulb set up. It's kind of dim, and it is set on the power supply is set on with a voltage of 2 volts. What I'm going to do next is turn it up to 4 volts, and you should predict what's going to happen to the light bulb when I double the voltage of the power supply, which is like doubling the height of the hill. Okay, here I go. I'm going to double the voltage. And were you right? Okay, here's another question we can ask. What would happen if I reversed the wires so that the electrons flowed the other way through the light bulb? Okay, I'm going to switch the wires from one side to the other side. And what's going to happen? That. Were you right? We have a tool called a voltmeter that can measure the voltage from one side of a light bulb or something else to the other side. And what it's doing is measuring the difference in height between one side and the other. And the units will be volts. So if I take these two wires, I can touch them to two different things, and it will read the difference in voltage between the two things. So if I touch them there and there, it should say 4 volts, because that's what I've set the power supply to, and the light bulb is connected directly to the power supply. So one side is at the top of the hill, 4 volts, and the other side is at the bottom of the hill, and there's 4 volts difference. Another question we can ask is, what will happen if I add more light bulbs? So I have 2 more light bulbs. Let's make a circuit with 3 light bulbs total. And there's various ways to connect those, but I'm going to connect them all in one line. So I'm going to go from one light bulb in and out of that light bulb to the next light bulb and to the next light bulb, and one circle. And that is called a series circuit, because it's all in one series, all in one path. And the question we can ask is, now if I turn on the power supply to 4 volts, what is going to happen to the light bulbs compared to how bright they were before? So I can refresh you. This is how bright they were with one bulb. This is how bright it was with one bulb. And now you predict what's going to happen with these 3 light bulbs. There are a couple different questions for you to ask. This is part 2 of the lab, and it asks you in 2B, do you expect more, less, or the same current to flow in this circuit than in the single lamp? And current is how much electrons per second are flowing through there. Do you think the lamps in the circuit will be brighter, dimmer, or about the same as they were for a single lamp? And do you think one of the lamps in the series will be brighter than the other? Will one of them use up all the electrons and there won't be any left over for the other ones, or will they be the same? Which one, if you think one's going to be brighter than the others, which one do you think is going to be brighter than the others? Remember, this is the negative side and this is the positive side. G, letter G in part 2 asks you, what do you think will happen if we measure the voltages across the individual bulbs? How high, what will be the difference in height between one side of the bulb and the other side of the bulb for each different bulb? Okay, pause the video, answer the questions, make predictions, and then we'll turn it on. Okay, now I'm going to turn on the power supply with the 3 light bulbs connected so we can test all of our predictions for part 2. So if I turn it on, let's see what's going to happen. Okay, is that what you thought? It looks to me like all the bulbs are the same brightness and they're a little bit dimmer than they were when there was just one bulb. And let's see what the voltages say. So if I take the wires and connect them straight to the power supply, it'll tell me how high the entire hill is. And I do that, and it says about 4 volts, which is what we thought. Now, if I go across one bulb, how high is it from one side of the bulb to the other? How much height difference between one side and the other? So I'll do this bulb. What did you predict? Let's see. About 1.3 something, okay? Is that what you predicted? What about if I do this bulb? About 1.3. And what about if I do this bulb? About 1.3. Okay, here's another question we can ask. Now, what would we have to do to the power supply to make the bulbs look as bright as they did when there was only one bulb with 4 volts across it? So right now we have 3 bulbs in series with 4 volts. And I want to turn up the power supply so the lights get as bright as they were before, and that was with 4 volts across one light bulb. Right now we have 1.3 volts across each light bulb, as you can see on the voltmeter. So pause the video, guess how high I have to turn the voltage on the power supply so that each bulb is as bright as it was before. So I'm going to turn it up until there are 4 volts on one bulb. There we go. And what did you guess? Well, the power supply is at 12 volts. Did you guess that? Here's one more question we can ask. What will happen to the bulbs if I unscrew one of these bulbs so that the current cannot flow through it anymore? What will happen to the other 2 bulbs? So I'm going to unscrew this bulb. You predict what's going to happen. Okay, ready? Predict. Here goes. I'm going to unscrew it. And the other bulbs stop. What if I unscrew a different bulb? This one. Aha. And another thing, what happens if I put a wire across this bulb so that the electrons can flow through the wire instead of having to go through the bulb? I'm giving them a short circuit or a shortcut around this bulb. What do you think is going to happen to the other bulbs? Okay, make a prediction and then we'll see what happens. Okay, here goes. Looks like the other bulbs got brighter and this one went off. Take it off. What if I short across a different one? Aha. Okay. Was your prediction correct? Okay, here's another question we can ask, and this goes with part 3 of the lab. Could we connect these 3 bulbs to the power supply in a different way, and what might happen? So I'm going to show you a different way to connect them. Remember, this one is called series and what a series means, it's all in one path. Here's a different way. And this way is called parallel because it's like parallel lanes of traffic on a highway or something like that. So now I am going to connect these so that each bulb is in a separate path. And can you see that? Yes. So now from the negative of the power supply, electrons can go through this wire, through this bulb, and back. Or they could go through this wire and over to this bulb, and through this bulb, and back. Or they can go all the way through this bulb and back. So there are 3 separate paths instead of 1 path. Question to ask now is, what happens if I set the power supply to 4 volts? How bright will the bulbs be compared to they were with 1 bulb or with the 3 bulbs in the series circuit? We can also try to predict whether 1 bulb will be brighter than the others, whether they'll be all the same. And we can also predict if we put the voltmeter across a particular bulb, will they all, what will it say? Will it be different on the different bulbs? And how much will it be if I turn the power supply to 4 volts? Okay, make all those predictions and pause the video and then we'll try it. Okay, now I've set the power supply to 4 volts. We're going to turn on the bulbs and see how your predictions did. Here goes. So it looks like they are pretty bright. And let's measure the voltage across each bulb and see what this meter says. So the first one says about 4 volts. What is the second one going to say? About 4 volts. And the third one, what do you guess? Yep, 4 volts. What will happen if I take out one of the bulbs? If I unscrew one of the bulbs, will the current still be able to go through the other bulbs? Pause the video, make a prediction, and we'll find out. Okay, I'm going to unscrew this bulb and see how that affects the other bulbs. Didn't look like it affected them. What if I measure the voltage across the other bulbs now? Well, what will happen? 4 volts there, 4 volts there. Screw that back in. What would happen if I put a wire across one of these bulbs and shorted it out so that now all the current could go through the wire instead of going through the bulbs? It could get from the negative to the positive only going through wires and not having to go through any bulbs. What do you think is going to happen to the bulbs when I do that? Here goes. Aha. Looks like the current prefers to go through the wire instead of going through the bulbs because the wire is a lot easier to go through. Okay, in parts 4 and 5 of the lab, we're going to look at other ways to connect 3 light bulbs together. We looked at a series circuit and we looked at a parallel circuit. Now we're going to look at a combination. So part A in 4 says, draw a circuit with 2 lamps in series, A and B, and that combination in parallel with a third lamp, C. So make your best attempt to draw that circuit before continuing the video, and then I'll show you how I would do it. Okay, so it says 2 lamps in series, A and B. So I'm going to take A and B and connect them end to end like that in series. And then it says that combination in parallel with a third lamp, C. So my series circuit, I'm going to make another parallel lane which involves bulb C. So I'm going to put that in parallel like this with A and B. So now A and B are in a line and C is an extra lane, say, of the highway. And we have to connect that all back to the power supply. So back to there, to there. And I'll put a black one over here. That is how I would connect 2 lamps in series in parallel with a third lamp. A and B all in series and C in parallel. Now go ahead and make a bunch of predictions and then we'll test them out. Okay, here now we're going to test out all your predictions. So first thing I'm going to do is turn on the power supply and see how the brightnesses of the bulbs look at 4 volts on the power supply. So it looks like bulb C is bright and A and B are dimmer. Is that what you predicted? Now I'm going to measure the voltages across the different lamps. So let's see what happens. What did you predict for the voltage across bulb C? It says about 4 volts. What about A and B? This one is about 2 volts. This one is about 2 volts also. And now it says, what do the voltages along any path always add up to 4 volts? So if I pick my A and B path, I'll go across the whole path, and that says about 4 volts. Now I'm going to choose the path that only goes through bulb C and measure across bulb C, and we already saw that's about 4 volts. So any complete path. Okay, now I'm going to remove bulb A and see what happens. B goes out, C stays the same. Okay, now I'm going to short out bulb A, which means I'm going to put a wire across so the electrons can flow through the wire instead of having to go through the bulb. I'm giving them a shortcut. And what's going to happen is that bulb A went out and B got brighter and C stayed the same. Now I'm going to do the same things with bulb C. I'm going to remove it first, make a prediction. Looks like nothing happened to A and B. Now I'm going to short out bulb C. What's going to happen to A and B? Everything went off. Okay. Okay, so part 5 has a different combination circuit with 3 bulbs. It says to put 2 in parallel, A and B, and that in series with a third lamp, C. So first of all, try to draw what that looks like, and then come back and look and see how I would do it. So it says 2 lamps in parallel, A and B. So I'm going to take A and B and put them in parallel as like parallel lanes of traffic, like that. Okay. A and B in parallel. And then it says that is in series with a third. So what I'm going to do is take that combination of 2 and then make that in line with a third so I can connect either side of here on A and B. And now after going through A and B, it narrows down to 1 lane, which is C in series. And I'm going to connect that to the power supply like so, just at the top of the A and B, at the top of the hill. And then I'm going to take the end of the circuit and connect it back to the power supply, like so. And my wires are a little messy, but there. A and B in parallel and series with C. Now, go ahead and make all the predictions in the lab and we will test them out. Okay, time to test the predictions for part 5. I'm going to turn on the power supply at 4 volts and see what happens to the bulbs. And it looks like bulb C is bright and A and B are on, but they are very dim. I don't know if you can see that. Now we're going to measure the voltages. What did you predict for the voltages across each bulb? Let's try bulb A and B. A says 0.8, or B says 0.8. A is the same, 0.88. And what about C? It's about 3.2. So that one's a tricky one. I bet you did not predict that correctly. It's very difficult to predict that one. But see if it makes sense now that you've seen it. And now we're going to take out A and C. So I'm going to remove bulb A what happens? B and C are equally bright. Now I'm going to short across bulb A with the wire. I'm going to short it out, make a shortcut through bulb A, and bulb B goes completely off and C gets bright. Now I'm going to remove bulb C. What's going to happen? Everything goes off. Can you see that? Because C is in the main, all the current has to go through C to get back to the power supply. So if I take it out, nothing can get through. Now I'm going to short out bulb C. Short across bulb C, and A and B get very bright. Okay. Hope you made predictions. And now you can use all you've learned in these parts to figure out the mystery boxes which are coming next. Hi everybody, here's a box we have of 4 different light bulbs, and it's connected to a power supply, and if I turn the power supply up, the light bulbs go on. All 4 of them go on, but 2 are brighter and 2 are dimmer, which is interesting. Why would that be? It depends on how the light bulbs are connected with wires. So your job is to try to figure out this mystery of how the bulbs are connected to each other based just on this, and we're going to also do a bunch of experiments. I'm going to demonstrate taking light bulbs out and shorting the light bulbs, and you can pause the video and rewind and go to different places and see how the experiments work, and from watching it you should be able to try to draw a circuit diagram of how these are connected together and draw something and then test it. Does it work with this experiment? Does it work with that experiment? And if any of the experiments contradict what you've drawn, then maybe modify your drawing and keep going until you find something that seems to work with all the experiments. Okay, good luck and have fun. I'm going to remove bulb A. Remove bulb B. C. D. Now I'm going to remove both A and B. Now I'm going to remove both C and D. Now I'm going to short across bulb A, short across bulb B, C, short across bulb D, Okay, so let's go over box number 1 together so you can make sure you're on the right track before going on to box number 2 and 3. So before watching this, make sure that you have tried your best to draw a circuit for how these bulbs are connected for box number 1, and tested it out by going back through the video and making sure you're pretty confident that it works. So here's what I would do. Okay, so first thing I'm going to do is I'm going to remember that when I took out bulb A, everything else went off. So that makes me think that all the traffic has to go through bulb A, or all the current has to go through bulb A. So what I'm going to do is just do bulb A first, because the order doesn't really matter, and I'm going to draw a line, and I'm going to say, I'm going to make a little symbol for a resistor, call it A, and I'm going to say everything has to go through A. And then also I remember that the same thing happened with B. So it looks like all the traffic, all the current has to go through bulb B. So I'm going to go make the lane continue, go through bulb B, and say everything has to go through bulb B, there's no alternative. But then I remember if I took out bulb C, that A, B, and D kept going. So, and the same thing with D. So it looks like all the traffic does not have to go through, all the current, I'll start using current, all the current does not have to go through C or D, so it looks like there's an option there. So I'm going to say, oh, well maybe it splits in half and it has a choice to go through C or D, and then it comes together again like that. So now if I take out bulb C, all the current can go through A, B, and D. If I take out D, all the current can go through A, B, and C. And if I test that out, that looks pretty good. And so to finish my diagram, I'm going to draw a power supply like this and connect it to the top of the hill and the bottom of the hill. And there's my diagram. The power supply lifts the skiers up to the top of the hill. They all have to go through A, they all have to go through B, and then they can split and go through either one of C and D. So, did you get that right in your original drawing? And hopefully that'll help you with how to think about it with box number 2 and 3. Okay, so here's mystery box number 2. It's connected to the power supply, and right now the bulbs are all about the same brightness, and I'm going to run through different things that you can use to try to figure out how they're connected. First, I'm going to take all the bulbs out one at a time. So here we go. Take out bulb A, bulb C goes off, and B and D stay about the same. Take out bulb B, take out bulb C, take out bulb D, bulb B goes off. Okay, what if I take out 2 at a time? I'll take out A and B. C and D go off. What if I take out B and D at the same time? What do you think is going to happen? Let's see. Take those off. Now I'm going to use a wire to short circuit different bulbs, and see what happens. So I'm going to short across bulb A, and it looks like C got brighter and B and D stayed about the same. Now I'm going to short circuit bulb B, and bulb D got brighter. I'll do one more, I'll short circuit across bulb C, and bulb A got brighter. Now you try to draw a circuit. Keep modifying your drawing until you think it explains all those experiments. Okay, here's mystery box number 3. Some people find this to be the most challenging, but now you have lots of experience. To start with, it looks like all the bulbs are about the same brightness. And now I'm going to do various experiments you can use to help you draw the circuit diagram. Here we go. Take out bulb A. Looks like C and D are on still, but they're very dim. B. Again, C and D are dim. A and B are dim. A and B are dim. And now I'm going to short circuit different bulbs, starting with bulb A. Short circuit B. Now B is completely off, and so is A is completely off. Bulb C. C and D went off, and bulb D. Okay, good luck.
Hi folks. So you've hopefully done this lab with John, and I hope you've had some fun looking at the mystery circuits, because the mystery circuits are the key to the whole thing. If you understood it, you can do the mystery circuits. Now remember, if you unscrew a light, anything in series with it will go out. Anything in parallel with it will probably get brighter. Think about that. So here's your assignment. I need you to draw on paper your best guess at how the mystery circuits work and play with them a little bit and make sure that your drawing does what you think it should do. And you need to email that to me. And please say, I did the quiz and here's my mystery circuits. And if you do that, you'll get credit for the circuits lab, okay? And next week is crazy fun. I don't know how we're going to do it without being in the lab because it's a field thing, but we're going to do magnetism. So that's your assignment. Give me 2 little drawings and tell me you did the quiz, and that'll do it for this week's lab. That's it. Bye.